we've practiced graphing from vertex form, and we've looked at it from standard form, but there are patterns to the way things move around that we can use to make things a little bit easier. We start with f of x equals x squared, right? That's the one that we refer to as the parent function. It's the simplest, it's the most basic, it's the one that happens before we start changing anything. It has all the characteristics. It's got the x squared, which is going to make that parabola shape, but it hasn't gone anywhere. It hasn't been changed in any way. So if we bring back our table, right, for f of x, we've been starting with the 0, 0, 1, 1, 2, 4, and we plot those points. 0, 0, that's where our axis is that we're going to reflect everything across. 1, 1, 2, 1, 2, 3, 4. Right? Plot the other points. And we can draw our parabola. Parent function sitting at the origin. Okay. Well, if we look at the function notation and we look at our new equation, I've got my original x squared function, and then this plus 4 out here just says, okay, take everything we already had and add 4 to it. And when we do that, we're adding it to the y values. So our g of x table, if we start with our original values and add 4 to everything, then I've got 0, 4, 1, 5, 2, 8. So I'm going to plot 0, 1, 2, 3, 4, 1, 1, 2, 3, 4, 5, and 2, 1, 2, 3, 4, 5, 6, 7, 8. When I reflect those across, I have my new g of x parabola. It's the exact same shape, it's the exact same proportions as the original one. It's just moved up those 4 units. Okay. So if I want to just use that knowledge to graph my last one, h of x, this minus 5 out here tells us it's going to move down 5. So I'm going to use my original points, 0, 0, 1, 1, 2, 4, but before we plot everything, we're going to move down 1, 2, 3, 4, 5. And then just like before when we were looking at vertex form and if we had to do any stretches. So from here, this is our new 0, 0. And I'm still going to plot 1, 1, 1, 2, 1, 2, 3, 4. Reflect those across. And I still have the same shape, same proportions. It's just moved down 5. So what we can write down for later reference is that adding at the end moves up, and subtracting at the end moves down. Okay. And so that's all this describes right here. Adding at the end moves up, that's f of x plus d. Adding at the end, f of x minus D. Okay. The basic shape, the point relationship, see we've still got our original relationship. None of that changed. I'm just picking up my graph and physically moving it straight up or straight down. Okay. The outside ones are original, exactly what they say. Okay. What happens when we start messing around inside the parentheses? Well, we'll graph our original parent function. 0, 0, 1, 1, 1, 2, 1, 2, 3, 4. Right? But this time, we're adding 4 on the inside to the x values. So my original set of points, 0, 0, 1, 1, 2, 4, now my y values are going to stay the same, right? But we're changing the x's. And g of x is x plus 4 squared. So what this is telling us is that to get back to our original values, we have to add 4 before we square anything. So if I were going to take that out and use it, this tells me that the way x is changing, I have to subtract 4 to know what my original x was. Okay, and if we're subtracting, that indicates that we're moving to the left. So this plus 4 says move everything to the left 4 units. So I'm going to come down here. So my 0, 0. I'm going to move back to the left, 1, 2, 3, 4. That's where my 0, 0 is going to be. And then I can plot my original 1, 1, 1, 2, 1, 2, 3, 4. Overlapped with that one, that's okay. When we reflect them across our axis of symmetry. Same size, same shape. We've just moved it over to the left. Okay. And h of x, there's our minus 5, but it's inside, which tells us we need to add 5. So we're moving right 5. So the minus in here, right 5. So from my 0, 0, 1, 2, 3, 4, 5. And then the same size, same shape. All we've done is that single transformation. 1, 1, 1, 2, 1, 2, 3, 4. Sketch axis of symmetry in there so it's easier to reflect across. We don't have to keep up with anything. Again, same size, same shape. All we've done is move it over to the right, those 5 units. Okay. So again, all this is telling us is that when I see f of x minus c, some number, not the c we're used to from standard form, just that c is just sitting there because it stands for some constant number that we plug in. That tells us we're moving right f of x plus some number c means we're moving left.